All right, we can get started.
Yeah, let's get started. So, good evening and welcome back to anyone who's attended one of our online sessions before. Welcome to anyone joining us for the first time tonight, and a big shout out to anyone who attended our in-person on Saturday at St Al's, as Tony was saying. There was a really positive buzz about the place. We had a range of presentations, tried to take some of the work that we'd done in our online sessions and make them into more concrete tasks that are going to be available for classroom teachers.
Yeah, this evening and the rest of the week, we are basically just finishing this year's upskilling events, and we really hope you have found something useful in them. As you know, there are web and database sessions on Tuesday and Thursday of this week. However, STACS are working away in the background on editing all the videos and producing these teaching resources, which will all be available to you on the STACS website.
Yeah, it's going to be really helpful because I know I've still to see some of them as well. So certainly for logging into it, I found that I've been using my Google account rather than my school email, because Glow and school emails don't always give access to the shared folders and drives. So bear that in mind. You might find it easier if you do have a Google account to use that.
Yeah, what would also be really helpful is if you have any feedback whatsoever on the sessions, or any resources or ideas that you think would be useful going forward to keep obviously advancing computing science, keep our subject alive. We'll say more about evaluations at the end of tonight's session. So obviously, as usual, reactions are at the bottom of the screen. So if you want to interact with reactions, go ahead. Just make sure you know how to do that. And if you do get lost, just you could go out and exit and rejoin via the chat. Okay. Do we need to? We don't need to read. I think everyone knows who we are now, Fiona.
I think so. Yeah.
I think so as well.
So for tonight's session, what we want to try and do is to try and tie together probably a few loose ends of the software development topic, and with it being the coursework season as well and sort of looking forward to exams, we're wanting tonight to maybe try and suggest some strategies for how we can prepare our students for that sort of unknown problem solving aspect of the coursework and also the exam questions as well.
Yeah. What we want to do is we're all really wanting to develop computational thinkers in the class. We don't want the pupils to memorize the algorithms by heart. Instead, we want them to understand the logic of what they're doing and then be able to apply them to solve new problems that they've never seen before, rather than being thrown by coming across the standard algorithms, but in a slightly different context.
Yeah, so for tonight, in terms of our start, we're going to try and have a quick recap of the four main principles of computational thinking.
Yeah, Jeanette Wing in 2006 was the one that really distilled the essentials of computational thinking, building upon some of the work of some big names like Seymour Papert.
Yeah, so her initial research had been developed and refined for these four key aspects. So we've got decomposition, we've got pattern recognition, abstraction, and the fourth and final one of algorithm design.
Yeah, there are some other concepts included under the umbrella of computational thinking, evaluating, logical thinking, and debugging, all skills that we want to try and develop in our pupils.
Yeah, so for sort of looking at these four key elements, we're going to look at how we can apply these skills to solving assignments, maybe programming tasks as well, but also how we can use them for answering your exam style questions too.
Absolutely. Just very quickly, for anyone not too familiar with computational thinking, decomposition is when we're breaking down a large problem into smaller, easier to solve problems. Pattern recognition is spotting the repeating elements or parts of a problem that you've seen before.
Yeah, that term there, abstraction, so that's getting our pupils to understand how they can sort of ignore any irrelevant information from a particular question and how they can focus on the essential part that's going to allow them to get hopefully full marks. And obviously for algorithm design, that's going to be identifying the steps in order for how they're going to try and solve the problem.
Yeah, I know my guys, quite a lot of them find it really quite difficult to ignore the extra information that appears and find their way sort of to the heart of it. Wing said, and I think we'd all agree, that computational thinking is a fundamental skill for everyone, not just for computer scientists.
Yep. So what we'll try and do is apply some of these principles to some of the tasks that we'll see at Nat 5 and also higher. So on this slide here, this is the problem description from, I think it's a 2021 assignment. And I think as well, it's been used for this year's specimen paper as well for the National 5. I think that's been updated.
I think it is.
School year.
Yes. This is the reading age one, isn't it? With the average word length. I was just using that as a practice task a couple of weeks ago, actually, with my Nat 5s. Assignment really is the biggest challenge that our pupils face at Nat 5. Programming task that can really make a difference to their overall grade. It can make such a difference, but it's essential they're equipped with the skills to interpret and solve this task, because of course they're going into it. It's unseen to them, and we're expecting them to think on their feet, aren't we?
Yeah. And again, when you're saying there how it's important, that's probably the difference between, for some of our pupils, it might be the difference between getting a B and an A, maybe the difference between maybe getting a D and a C as well. So
absolutely.
We can try and give them sort of as much confidence as possible to interpret what the coursework is asking them and how they can actually try and get a solution. So our aim is obviously trying to guide them through examples like this, how we can sort of model this computational thinking approach as well, so that they can break it down, and particularly breaking down the problem in the way that ourselves as teachers would do when we sort of see these tasks each year.
Yeah, we've got the experience with the tasks, so we look to see the data structure being used, the algorithms used, the predefined functions we're going to use, and what programming structures that are going to be shown in the design that the SQA give to the candidates.
Yeah, so what we'll try and do is, if we take a look at the design of the program, so this is a structure diagram for it, and we want to maybe try and articulate questions that we'd probably be asking ourselves in our head. So if we can maybe tease out these questions in an example coursework task, then the aim is that we can encourage the pupils to maybe ask themselves similar questions when they're completing their own coursework.
Absolutely, and making it very explicit, making it very sort of the thinking very visible. If we look at this structure diagram, which was given out to the candidates, really important to stress to pupils that their code must match this design, even if they can spot other ways to solve the problem. Quite often, my better ones will, some years do it in a more efficient manner. They don't follow the design. And it's trying to, when you're practicing with them, get the point over to them that they've got to follow the design that they've been given.
Yeah.
Another tip for the coursework and exam is that the paper is theirs, and I encourage them to highlight, underline it, use colour on it, annotate notes at the side, whatever they can to make things stand out and highlight the key information. Yeah, so this is the structure diagram here on this one again. And one of the things that we can do with them is get them to identify all the inputs. And people could do this in different ways, depending if they're using it on the interactive board or they're using it on their class notebook, maybe on Teams. But if we can circle them and we can think about the data type for the inputs and whether or not they're single variables or is there a series of them, or are they going to be stored in an array? And that can let us begin to think about how we're going to declare and initialize our variables and our data structures.
Yeah, so if we're looking probably at this example here, we can see that we would have the getting a valid number of words in a sentence. That's going to be one of our examples for the input, and then the same for, again, that keyword there, get, getting and storing the next word. So it's about getting those values from the user. They're the key things that we want to try and highlight at that 5 level for the inputs. What are we getting from the user?
Yep. Excuse me. We'd be thinking integer for the number of words and string for the next word. Arrays on this, though, are not mentioned explicitly, are they? So the pupil, we've got to get them asking themselves, for instance, when they get the valid number of words that we've circled there, is to get them thinking about how they're going to store that, and if it's more than one, is it indicated here, the hints there, then they need to spot that they're going to be using an array, or as we saw in the last one there in June, a series of arrays.
And I think with this one as well, when they're maybe trying to look at how you would get your arrays, if we're looking at that second input there where it says get and store the next word, maybe that would be a hint that we're going to be storing more than one thing within the same construct. So it's all about trying to sort of highlight these to the pupils so that they've got a wee bit of an understanding going into the coursework. The processes and the programming constructs we'll be using in this task. So we can see, again, we've got these sort of 4 definitions here down at the bottom. We want to try and train pupils to ask questions about, it could be loops, decisions, standard algorithms, maybe the predefined functions as well. So this would be the pattern recognition. And we can probably expect to see maybe a wide range of constructs used from across NAT 5. But if we analyse a few assignments with pupils, that's when you'll maybe start to see this sort of pattern emerging.
Absolutely. I mean, we'll definitely have loops in the NAT 5 coursework. Let's look at the keywords that would flag up to pupils that loops are required. And then we can ask them, once they've decided they need a loop, we'll ask them whether or not it's going to be a fixed loop or a conditional loop. That's their next decision that they're going to make. In this case, we're going to loop for each word, and it says looping for each word uses the for keyword, so we know that it's going to be fixed and not conditional. And it's going to be the same when we come to display the next word on a new line. There's going to be a conditional loop too, but we'll flag that up in a moment.
Yeah, so selection is likely to be used also. We'd probably see the if statement in the pseudocode, or maybe the branching of like yes or no, or maybe true or false choices in a structured diagram, or maybe even a flow chart as well.
Absolutely. So we'll drag the purple boxes over the hexagons. There we go. There. Drag that one over. Oops, sorry. Okay, there we go. And that takes me on to thinking about the if, elif, else, and getting pupils to think about that. When I did this with the guys, we talked about this, and I actually got them. I said, look, we're taking decisions here. Let's write on where we're using an if, where we're using an else if, and where we're using the else, because we'd been talking prior to that about efficiency, which is something that they quite often get asked to comment on, isn't it? So that got me into getting them to highlight their if and their else ifs.
Yeah, so even just with these orange boxes here, we can maybe see with some of the loops that we're looking for here. So we've got one of the loops here. We've got another one here as well. But we're probably also going to see that there's maybe like 1, 2, possibly even 3. There's obviously 3 NAT5 algorithms that we need to know about. We could be using all 3. So if we maybe see the word valid here, just in that very first
right
spot,
at the start there.
Yeah, if we can see that word valid, then that maybe suggests that we're probably going to be doing input validation. So if I can sort of drag this one here just to highlight that for you. So input validation being here, and then the word total as well.
Okay, yeah.
So again, that's probably going to be
total.
Yeah, so that's probably going to be your running total as well. And again, sort of with the word total itself, especially if it's in a loop, it's going to be a big hint to on that 5 pupils that we're looking for that other algorithm here.
Absolutely, because I have in my mind that it's not always, especially the input validation, has maybe not always been completely explicit, but it's something that's expected of them, isn't it?
Mm-hmm.
Okay, so then we go on to traverse an array. Now this can be a bit trickier for them to spot, or it might be part of another algorithm. So getting and storing is traversing and populating the array. Then displaying the next word is also the same. So if we could duplicate that text and label both examples, the traversing the array, drag that over. Where am I going for this one? Getting and storing next word and populating the array.
Yeah, and then displaying that next word on a new line.
Displaying the next word on the new line.
Yeah.
Spotting these should hopefully push the pupils towards using their fixed loop and realizing that they're going to do something to every item in that array, in that list.
Yeah, and then finally we've got these predefined functions, they're keywords to sort of look out for: random, round, and length. So if we start with the length one, I don't actually having a look at it. In fact, I don't think there is any examples of random or round used here. So the length will obviously go here for calculating the length of the word. And again, it appears in the next box there as well, adding length of word onto total. But just looking at this example as well, because I did it as well with my pupils recently, and then maybe asking do they need to use round for the average just in this box here? But if it doesn't state it, then obviously there's no requirement for them to use it. So it's about making sure that they're only using those sort of predefined functions if it sort of shows them in the structure diagram that it's required.
Yeah, because I find sometimes even some of my better pupils are really, really keen to put in as much as possible, aren't they? They don't just stick to the design that they've been given. It's almost as if they want to shoehorn in extras.
Yeah.
And I mean, our diagram is kind of becoming complicated enough without them adding on anything else. But it gives us so many clues on exactly, it should give them clues on exactly what code they're going to need to write. And even if there may be, as well as doing this onto the structure diagram, they could maybe be jotting it down in a document or on a bit of paper or in a jotter, some notes as they're doing this, also to give them just a sort of aid memoir. And since obviously this is an open book assessment, then they can refer to the notes and previous tasks. And this is what I've been drumming into them, to go back to all the previous ones that we've worked on, and look at the notes that we wrote down at the time and the things like this that we've annotated. and also to look back at their programs, where even if they haven't always been the best at solving them and getting their code to work, eventually they will get, a working version of the task that we've been doing, which they can look back at and use.
Absolutely, aye. So if we just finalise this sort of structure diagram here with the last part, which would be our outputs, and that's going to either be maybe like your print statements, or it could be your message boxes, whichever sort of command you use to display output on the screen for the programming language that you use.
Yeah, SQA diagrams in the SQA reference language will ask to display. So let's drag the red boxes over each display block. So hold on, plug it up. Nope, I'm not managing to grab that one. There we are, there's one. Connor, you could drag one for me.
Aye, sure, yeah. So just those different boxes that we've got. There's me doing the same thing as you.
I know it's awkward.
Do that last.
Yeah.
Twice we've done it. Yeah. So anywhere that we can see the word display, that's going to be our output. So that should hopefully be the ones that maybe pupils would be a wee bit familiar with if they see that keyword display.
Yeah. We can just think about their concatenation to display the average, and strings to match the design in the structure diagram.
Yeah, and obviously as teachers as well, there's probably an awful lot of detail there for some of the pupils, but I think as teachers, we'll have the sort of mental framework and maybe experience to already sort of spot these constructs and patterns already.
Yeah, we can arrive at them quickly. Whereas pupils might be, some of them probably will be a bit overwhelmed, won't they, when they get sort of this kind of information handed out to them. But what we are suggesting is modelling this with example tasks to show pupils thinking processes, so that they've been through the thinking processes beforehand, to try and make it maybe a bit less daunting when they get the actual one out. And they can then go back to the thinking processes that you used in previous ones and adopt the same approach, encouraging them to label, highlight, have different coloured pens available for them, anything that really pushes them in the correct direction, so that they're highlighting the important relevant information.
Yep, anything we can do to help them, really. So for this slide here, obviously we can see those sort of computational thinking approaches that we've tried to highlight there, and we can sort of see that these are the skills that we're really wanting pupils to maybe identify, but also develop as well. Lucinda, I'm just going to hand this over to you just now. Is that okay?
Yeah, sure.
Yeah.
Right, okay, so next we are just going to have a look at higher coursework. So what we have here is the specification of the 2023 higher coursework. Now, the first thing that people might be asked to do is, for example, highlight the processes which are required. And in terms of processes at higher, we probably want to focus on the various algorithms that our pupils need to know, as well as predefined function. So if you look through the text, we're basically looking for anything that might mention a linear search, or counting occurrences, or find min and max. Now, we were already given the first process over here, which was the find names of the attractions with the lowest number of visitors. So at least pupils know that they have to do that.
Yeah, so we can see that it does mention that it will find the names of the least visited attractions and the most visited attractions. So that would obviously suggest that you're going to need the find max in there as well in order to find the most visited. But it does sort of seem that we need to find the name as well of the most visited attraction. So I think that's maybe the key bit that maybe pupils would have to try and understand. It's not just the value we're looking for, we're looking for the corresponding name as well. So in addition to that find max, we're also going to need a linear search. So we'll come back to that a wee bit later on, but it does sort of mention identifying the roller coasters that need to be serviced within 7 days. So that one there that's highlighted in pink down at the bottom. So that's going to need to be another process as well.
We'll now need to look at some data flow. And in this task, it asks them to refine step 2. So,
yeah, so for step 2, I think that was finding, there it is here, sorry, finding and displaying the name of the least and most visited attractions. So if we're thinking this through, you're definitely going to need to have the names, which is going to be your attraction array, and you'll also need the amount of visitors, but there shouldn't be anything else in there, just those 2 arrays being passed in.
Yeah, that's right. So another question we also need to ask is, does it need to pass anything out? So this question requires you to find and display. So that would be done inside the subroutine.
Yeah, so for that one, I don't think we're going to need anything sort of passed out from it.
Yeah, that's right. So I don't think we will need to pass anything out, obviously, because we're just finding and display within the subroutine. And for step 3, write to file. So the named roller coaster needing service within 7 days. So I'm going to need to pass in the names of attractions, and for me to work out if it needs a service within 70 days, I'm going to need days open as well.
Yeah, so if we're going back to something like, if we think back to that sort of previous session, it does mention writing to a file, but we need to sort of remember that if we're writing to a file, then that's not necessarily going to be an out parameter. So again, for this step here, we're not going to be looking at putting anything in the out box for that last and final step.
Yeah, that's right. So I don't think we need to pass anything out of that one. And for step 3, write to file, the named roller coasters needing service within 7 days. So obviously I'm going to need to pass in the names of the attraction. And for me to work out if it needs a service within 70 days, I'm going to need what? Days open as well. So if in higher, we need to work out if a file is being read into parallel arrays or array of records. And there's usually a requirement, or is usually given in the requirements. And look at the data flow we've been given. I can see that there's lots of arrays. So that obviously means that we need to use parallel arrays for this one.
Yeah, so if you're maybe looking at this and thinking a bit unsure why we've got 5 categories there, what we would encourage pupils to do is to look at the format of the file. So we notice obviously these commas that are being used to separate our values. So you'll maybe need to consider that when it comes to reading in the file, the particular order that you're going to have these values being read in. And I think the next thing to probably try and think about would be then, for the array, how many elements would there be as well?
Yeah, that's right. I mean, that's one way to look at it. I would definitely look into the file and look at the number of rows and columns in the file. So it's always good to advise pupils to, have a look at the data that you're trying to read from.
It always surprises me that the pupils don't just do that.
Want to do that? Yes.
Yeah, have you looked at this?
Have you looked at the file? That's
and they go,
you're trying to Yeah,
Yeah.
that's right. You're trying to read from a file, have a look at how many rows, how many columns are available, and what the record, what the data looks like in general.
Yeah, no, I mean, sorry, I'm kind of interrupting.
Yeah,
you,
no,
but
that's fine.
I was doing that today with one of the girls, and she hadn't looked at the file, and she still hadn't got her head round how we program Python, as you know, how we split up the data that we've read in and split it up into, it was parallel arrays as it happens, but the same would be true for an array of records, how it gets split up, the commas, how you and gets put into separate arrays. So I said, well, you need to open the file and see how the data's organized, and then you'll see it'll be much clearer.
If you don't look at the data, you might be trying to read in an empty file.
Well, exactly, and it doesn't make much sense.
Yeah, that's right. So at this point, we basically have a fair amount of our processes identified. So if I look at this refinement and I look at step 3.4, it mentions set days to current days open modulus 90. Now, obviously, we know that modulus, as teachers, we know that modulus means, obviously, we need to use a predefined function. It's going to basically help to calculate number of days until the service is. And as you know, the modular operation will return the remainder. So I'm definitely going to need to incorporate that into the calculation.
Aye, so if we're looking at this one here, there is a lot of processes going on, and I've noticed earlier in one of the other parts of the task, it's bringing in some string handling as well, and some count occurrences. I think for this bit, it was maybe, and again, it's maybe something for pupils to have a look at. Previous coursework tasks, they'll maybe have, if it's one of the key bits, obviously your 15 mark, usually software program that you've got to try and create. Sometimes previously it's maybe been 12 marks, and then they'll break an additional 3 marks into a question like this as an example. And again, it's about making sure that they can sort of highlight what's the extra processes that I'm having to put in this example here. Sometimes your programs can be sort of split up into 2 different tasks.
Yeah. But having a look at this, how would a candidate work this one out? So obviously the question does say that it wants an update on the attractions with a height restriction of 1 meter, as well as to implement a new subprogram to count and display the number of attractions beginning with 1. So the fact it says a number of attractions, this would indicate that a counting occurrences algorithm is needed.
Yeah, so but in addition to that, obviously it's saying the height restriction has got to begin with the character 1. So again, we're probably right in thinking that string handling is going to be involved there too.
Yeah, that's right. Definitely string handling would be needed to identify that first character.
On to our outputs at higher can obviously be a wee bit different, because we're looking at what's being sent to the screen, and then we're also looking at, is there anything that's going to actually be written to a text file. So in this case here, we can see that the top there example that we've got being sent to the screen is going to be the names. So those least visited and those most visited attractions, they're going to be sent to the screen or our output field. And then we're also going to be looking at, in terms of what's going to be written to the file, we are looking for any of those attractions who are going to have, as we can see the calculation there on 3.5. If that satisfies that condition there, then we're going to be writing the current attraction to the output file.
Yeah, that's right. Another thing to note here is to make sure that they do that inside a subroutine. Obviously, if it's been asked if they're being asked to display, we don't need to return the parameter, right? Because if we do return the parameter, then it doesn't match the data flow.
Yep.
So they should do it within display within the subroutine.
And again, one of the key things to note here is that if it does change from the given data flow, they might lose course. In fact, they will lose marks in the coursework, obviously at National 5 level, if it maybe differs from the way that it's laid out in terms of structured diagrams. They're probably going to lose maybe at most 2 marks, whereas if it's going to be at a higher level, because they've got to follow that data flow in terms of what parameters are being passed in and passed out, they can be losing quite a few considerable marks in comparison to National 5. So it's important that they try and sort of follow that data flow as much as possible.
Yeah, that's right. At higher level, there's obviously, we do have 2 options for output. So they might want to display to screen. One of the requirements could be display to screen or output to a file. And one of the given parts in the task requires pupils to write the names of information to file. So we've got to make sure that we are writing the specific data that is required to the file and not just everything else.
Yeah.
No, that's correct. Yeah. So obviously there's quite a lot we've went over there just with these 2 subtopics for this evening. So before we sort of move on to the exam questions, we're going to take the opportunity just now for any general comments or feedback on maybe those ideas, or maybe you might like to try and share, what you already do in class to sort of support pupils before coursework or exams. So just as we can see here, similar to what we've done previously, if you pick any of the post-it notes here or any of these sort of white squares that we've got on our screen just now, and you maybe want to just type in either some general feedback on those ideas that we've shared with you, or what do we do just now to sort of support pupils before these coursework tasks or exams. So someone's used the Nat 5 task today, yeah.
Yeah.
Yeah, just last week for me as well. So
yeah.
Aye. And again, folks, if any of you are like me, sort of struggling to see what's in the boxes, feel free to zoom in as well. You can just scroll in and you can see what other people have been writing.
Follow design, do not go rogue. Absolutely.
Yes.
But we know there's going to be somebody that will go rogue.
Yeah, oh, my girls, they love to go rogue.
Just add in a couple extra things.
They love to go rogue. Oh, this is not this. I could improve this design. No, that's not what.
But miss, this is not efficient. Yes. This is not democratic.
That's a good point there. So obviously we're talking about like trying to go rogue, but that post-it note there, I'm always telling pupils to follow the design, but if they can think of a better way to use, wait for the questions on the reflection.
Evaluation.
Like the evaluation part. Yeah,
yes.
That's a good point.
Yes, absolutely. Gives them something to write about there, doesn't it?
Yeah, that's right.
And then we've got those cheat sheets as well that we can use. Yeah, so they would help us out in terms of the programming part of it.
Different colours for input, process, output. Yeah, that's a good one as well.
That's a good idea, yeah.
Evaluation is your time to show off, yes.
There's actually a lot of good examples here. I think this is probably the most feedback we've had in terms of.
Yeah, that's right.
These are all really good.
Pick them all out.
Probably because we're all in the thick of things at the moment.
I know. Same boat.
Anyone got a surefire way to encourage pupils to mark up the course worksheets, as in their progress as they do them?
And that's one of the key ones there as well at that left-hand side. Give pupils the marking schemes. And again, that's
right.
Even sometimes they might not, like obviously when we download the marking schemes, maybe for future tasks as well, for future reference, there is quite a lot at the start that's maybe a wee bit wordy and maybe only directed for us. So maybe even it's a case of just picking out the bits that the pupils would really need. Maybe those exact bullet points that show them where they'll get their marks within the programming solution. Yeah.
Okay, good. That's good feedback there. Okay, so here we are, 2023, question 10. Let's go and focus on the high value questions, the 4 or 5 markers where they've got that big empty white space in a box, and there's, you know, a look of panic sets into some of their eyes while they try and figure out what they're going to put into this.
Sorry, Fiona, I'm still on that feedback slide. I'm just trying to scroll across here so that I can match up with you.
Can you follow me?
It's not giving me the option to go back, but I'm just matching where you are in your cursor just now. Sorry.
Okay, sorry.
Just in case anyone else was having that same problem, that was all. Sorry, probably just me.
You okay?
Yeah, that's me now. 3A. Sorry,
okay.
I'm with you. All right.
Okay.
So
good.
Yeah. So just probably for this one here, we're always wanting to encourage the pupils to write something. Obviously, marking instructions will show us that your marks are going to be awarded for indicating the loops, maybe decisions, initialization as well. I think is a key one that my pupils are probably a wee bit guilty of not doing, and it's missing out on some easy marks. You know, there's things like assignment and calculations as well. So even if they are confused, and again, it can be quite difficult, you know, if a pupil is confused with something, they might genuinely not know what to do at all. But we want them to try and at least write something down, because if they don't write down something, they're guaranteed to get 0.
Exactly. And if we look at this question, which was in the 2023 paper, it was quite a tricky one. Let's apply abstraction. And is there some brave individuals out there to suggest some key facts to focus on from this question? And is there any bits of information here? Is there detail that we can ignore? Because as we know, the pupils can get bogged down in that and can't see the wood for the trees. If there's anybody that would like to click on a post-it note and give me anything that they think is either relevant that we should focus on, or the things that we think are irrelevant, that are extraneous details, as it were. Okay, irrelevant steps 1 and 3. Store each month's data usage and display the average monthly data usage.
That's a fair point, because you just want to do like the very last sentence there, using a design technique of your choice, refine step 2.
Yep.
So 2 is the only one we're looking for. We don't need to do 1 and 3.
Yep.
And I see that so many times when I know this is an exam question, but maybe if it was like, we think back to that specimen paper for the specimen paper for Nat 5, and I think it's wanting you to do the breaking down how they can calculate the average, and again they start going through like initializing variables and sort of getting a lot of inputs that are irrelevant to the question, or that's maybe already been done. So
my kids love doing that. They go back over the stuff that's already been done in the SQ have given them, and they insist on starting with all those bits, and then by the time they get to the step that they should really be refining, they peter out a bit, don't they? They lose enthusiasm.
I know.
So what have we got here? Relevant 12 values. Yep, float values needed. Formula for the average, absolutely. Each month was stored in an array.
Yep,
And we're calculating for a 12-month period. Yes, so we know that how many values there's going to be in it.
Yeah, those seem spot on. And again, the irrelevant ones, communications company, again, yeah, that's meaningless, doesn't mean anything to us. The gigabytes as well, you know, they're
Yeah, we don't need the units, do we? Yeah.
Don't need them at all. All right. So yeah, those key things there that we're looking for. And obviously if they've got maybe, as you can see down at the bottom there, and they'll usually do this, if I've tried to highlight to my pupils that if there is a name that's suggested and it's in a different font, like we can see down there with month and av data, chances are they're going to want to see that in their question as well. So that's probably one of the things that we're wanting to highlight to them as well.
Yeah, good point. It's exactly, look out for it, and if it is there as a different font, then it should be slightly easier for them to pick up, shouldn't it? Yep, absolutely. Okay, yeah, I think we're spot on there. Yeah, move along.
We're thinking more about, when it comes to pattern recognition, we're looking at the constructs, we're looking at the algorithms, predefined functions as well. So we're just going to probably ask the same thing here as well. What clues have we got here about maybe data types and structures? What patterns can we spot as well? So again, with these post-it notes here, we're looking for that sort of pattern recognition there. So constructs, algorithms, predefined functions, what do we think would maybe be used here? Yep, as we can see, that's a good thing to spot, because February, March, July and August, they're whole numbers, they're integers, but obviously if we've got April, May and June being used with the decimals, then that's something that we're going to need to ensure that pupils use throughout that structure there. It's got to be an array of real numbers.
Yeah, and for the average, it's going to be a float or real number. So we're dividing the total.
And the running total as well. Yeah, that's going to be our algorithm there being used. So calculating the average monthly data usage. And that's probably the one that's most difficult to try and spot, I would say.
Yeah, that's right.
If they're trying to go through an array, they'll maybe just think that is second nature. You know, they might just take that as granted. But traversing an array is probably the one that's maybe most difficult to try and identify. Obviously, if you've got a running total, if you've got input validation, they're sort of clear, and you can maybe see that from the keywords. Sometimes you'll get a hint, but in terms of, that one there, traversing an array, that's probably the tricky one for some pupils to spot.
Well, yeah, because they need to have realised that it is an array they're using and not separate variables, don't they?
Yeah, there's several months, Yeah,
that they picked up on that from the start.
Yeah. Well, here's another keyword. See where it says data structure month? So that's a keyword to say, okay, I need a data structure here, and the only data structure we use in National 5 is arrays.
Exactly. Drumming it into them. I try to go, as soon as you see the words data structure, there's only one possibility. Input from keyboard, process data structure, output result. Absolutely. Okay, good. And on this one, we're going to decompose step 2 into a series of smaller steps. There's a bunch of work to do in step 2, so let's grab a post-it note and just do maybe a single line of the refinement that could be used.
So if we're going to try and break down step 2, calculating the average monthly data usage, obviously there's quite a few post-it notes here, but all we're looking for is one of your refinements. So it doesn't need to be all of the refinements within a single post-it note, maybe just one single refinement that would be used for step number 2. And then what we'll do for the next part is we'll see if we can try and put these refinements into a specific order so that we can create the solution for it.
Okay, good. So we've
got those.
Our refinements there.
Let's try to go through it all and think we've got it.
We'll move on.
See if it's going to work. So we're obviously wanting to initialize the total.
Initialize the total, as 0 at the beginning.
and then we're going to start our loop. So I'll just put these directly underneath one another. So within that loop that we're going to be running, we are going to be adding, so I'll drag in this one here. We're going to be adding the month to our total. And then, in fact, another good thing to do there as well is we probably want to, at the very start, again, initialize the average.
Yep.
So once we've done that there for our for loop, and we've added the month to the total, getting our running total going,
Running
we would
total, yeah.
obviously want to try and do our average just outside of it, so that can
Outside
maybe
our
go.
loop, yep.
Again, depending on how you would sort of lay out your structured diagrams, obviously you can maybe split them up into your sort of 3 different columns, if you like. You know, you could have your initializing at the left-hand side, you could have your for loop in the middle, and then you could have your final calculation at the right-hand side. There's different ways for you to obviously to lay it out, but that there hopefully would maybe give you an idea of how we can then get that algorithm design. So in an exam, we probably see some, as a marker as well, we'll see some really scrappy answers. And obviously when you're marking it remotely, you've got to scroll to the very, very end of the booklet, or that electronic version of the booklet that they've got, because pupils will maybe realise, like, maybe part way through a question that they need a loop, so they'll maybe score out their entire question and then they'll try and fit it in underneath at the bottom. So it gets really, really scrappy and really messy. But again, it's probably, we just want to try and remind pupils that as markers, we need to see legible responses. So if they do sort of muck up these types of questions where they're needing to use their problem solving skills, their design skills, they are more than welcome to score out their attempt. They can put a star and let us know where they've maybe reattempted the question. It could be at the end of the booklet. But if it does get too messy, you know, just rewrite a good final copy either underneath or at the space at the back, and again just score out anything that they've maybe done where they think it's either too messy, and just indicate where they want their final answer to be.
Absolutely. Hopefully, if pupils have been developing this approach in their programming tasks and in the assignment, then this thinking should transfer over to the exam and help them out when they are tackling a question like this, where they are faced by white space.
You know, they should sort of, you want your pupils to sort of be asking themselves maybe the same questions, like in terms of inputs, processes and outputs, identifying algorithms, structures and functions as well. So fingers crossed for you, maybe that walkthrough would be something that you would possibly consider doing with your classes as well.
I think I'm definitely going to try the sort of post-it note approach with them, because I've never done, with post-its before, but see, a bit like what we've done here on our board, but get them with post-it notes. This would be obviously for next year, to do a similar type approach where they can, work with a partner and do their post-its and then come out and stick it up onto, the board.
Yeah, the board, absolutely.
And start building it up like this, because I really like this approach where they can move their post-its about and sort of reorganise it. Yeah, good. Okay, I am going to hand over to yourself, Lucinda, I think.
Yes, that's fine. Here we're just looking at a past paper, a higher past paper about playing mini golf. Now, this was quite a difficult question for some people to access during the exam.
Yeah, no, I remember this. One of the problems was that a lot of kids had no idea about playing golf or mini golf, and the fact that you had to score less, a smaller number was a winner. So that that confused some of mine, I can remember. But they did find it quite difficult to work out everything that was required in this question.
Yeah, that's right, especially if they don't know anything about golf.
Exactly.
So obviously, we looking at this, we will bring back some of the work we've done with the 5 kind of questions. So we're looking for standard algorithms here as usual. So is there any parts that we can bring in so that we can identify what we need to do here? And looking at the tasks, the thing we're looking for is, we notice that Claire has won the most holes. So obviously, initially, we'll start thinking, how do I do that find max algorithm?
But then here's another thing. It also requires finding out the amount of holes that each of the two players has won. And they need to come up with the number of holes each person's won. So they need to do that as well.
Yeah, that's right. So obviously, if they need to come up with the amount of holes each person has won, then obviously you know that we need to count something. So we need a counting occurrences algorithm here. We have to think about the scoring for each player, whether Claire or Tina have either 1 hole in 1 or 0 hole in 1. So that's actually another counting occurrences. So it's not just the hole who won the game, but who's got 1 hole in 1 or 0 hole in 1 as well.
Yes. So they were actually keeping track of 2 count occurrences. One count was for who won the holes, and one for how many holes in 1.
If we look at how we can break this big algorithm up, we're going to basically bring back our slide algorithm from a previous workshop. So let's look at setting up our variables. So what variables do you think we're going to need here in order to do this?
We said that we need to count up the amount of holes that each player wins, because that's what's going to allow us to decide if that person has won the game or not. So I think we're going to need to keep track of a player A score variable and a player B score variable. Yeah, I think we need both of them, don't we?
Yeah, that's right. So looking at setup here, we are thinking about keeping track of the amount of holes in 1 using those variables. I'm going to need holes in 1 variable for player A and also 1 for player B. Okay. Obviously, in slide, I remember L being for loop. So I'm going to loop through the data, and obviously the data flow from the question, which had an array of player A scores and an array of player B scores.
Yeah, can I just say, when we're talking about the L for loop, we're talking about that mnemonic, aren't we? The slide mnemonic.
Yeah.
Which I don't know if Sandra originally came up with it, but I know Sandra was one of the ones that's been using it. And I know we had them out on Saturday. We had some printouts of that. I'm going to get one of those and put them up on my wall, I think, because I really, really like that. So yeah, so we're in the L for loop. So here we're thinking about, will it matter which of the arrays that I use to work out the length of my loop?
Well, no.
An array of player A and an array of player B, does it matter which one the pupils use?
It doesn't matter. As you can see over here, obviously the length of the array is exactly the same. So obviously we can use any of those.
Yeah, it's worth posing that question to them, isn't it? Getting them to think about it, because that's something that could maybe throw them.
So let's just move code block 2.
Yeah, so that's us got our fixed loop set up.
Okay, so next, looking at the diagram, who's won the specific hole, or rather, what do I have to do to win a hole in golf? Does give me an example that you win a hole if you've got fewer shots than your opponents.
Yeah, which is useful for some of them that don't understand it. But it means if I looked at the score for player A and it was less than the score for player B, then player A has won that specific hole.
Yeah, that's right. Obviously, it just means that you can use an else to say what the other player has won.
Yeah, so we've got our if there, haven't we? So comparing the player A score with the player B score for that hole.
Mm-hmm. Okay, so we've worked out who has won each specific hole in the game, but obviously now we need to work out who has won the whole game, and that's from D, from our acronym D. So
that's
increment the
that
respective
D
score by
standing
1.
for do, is it? Yep.
Mm-hmm. So though you'll see we have just copied our loop code from above, and to decide if player 1 has won, what I'm going to say is that player A score is increased by 1. Otherwise, check if player B has or if player B has won, and will increase their score by 1. Well, if they've drawn the hole, I'm not going to increment their scores, obviously, because it will just stay the exact same way. So that
Because
takes away one.
if their scores are the same for the hole, then it's a draw for that hole, isn't it?
Yeah, that's right. So if they've drawn, then obviously you're not going to increment their scores, and it will just stay the same. So that's obviously would take one level away from the complexity. Okay.
Oh, yeah, so that deals with drawing a hole then.
Yes, that's right.
Okay. Now,
so next we're going on to extra.
Yes, so for the extra, this is where we have to decide, is there anything else that has to be done? And the thing that we haven't done yet is to check for the hole-in-ones.
Yeah, that's right. So obviously while I'm still in this loop, I have to check who's won the hole. But what I can do is also check if they've got a hole-in-one. So if it's a score of 1, I'll increment my holes in 1 for that player by 1. Otherwise, I'll check if it's a hole-in-one for player B. And if it's not, I just won't do anything.
Yeah, there's a lot going on with the extras here, isn't there? Where we're now checking for the holes-in-one, because we're deciding we've still got to decide who has won overall, don't we?
Yeah, that's right.
Yeah.
So obviously now it's important that it's done outside of the loop. So it's important that it's done outside of the loop. So you'll see when we release, when we move the block here, when we reveal our code, you'll see that we have ended our for loop. And then we will check if player A won more holes than player B, in which case they've won. Otherwise, we check if player B has won. And if neither is the case, then it must be a draw.
Yeah. There is a lot going on with this question, isn't there?
Yeah, that's right.
So we just review a whole lot of the algorithm in one go here.
Yeah, so let's just move the plate. See if I can move this down so you can see.
Yeah, so now we've got our whole algorithm, haven't we?
Yeah, so we've got the complete algorithm here. So initially we set up our variables.
Yep.
So
we've set up our scores for player A and player B.
Player B,
and
yes,
the holes in one
for player A and player B. Then we loop through the arrays to obviously find, using our counting occurrences, who's scored a hole in total and who's scored a hole, or who's scored less than the others. Obviously, if you scored less at a hole, then you've got a hole-in-one. And then we decide who has won that specific hole. And then we increment the respective score by 1. But if each person scores the exact, then it's not incremented. Then finally, we check for holes-in-one and check who has won. Yeah, there's quite a lot to keep track on, but I think if they follow the slide,
I think so. I think that slide mnemonic can be really helpful.
Will be very
on Saturday in the one of the sessions, a couple of people were discussing applying the slide mnemonic to examples such as this, basically just to be very explicit, to show the pupils how the slide mnemonic would apply to this code. So actually sort of writing it down the side kind of thing, and, you know, maybe doing it in different colors and highlighting it to show this part of your algorithm here is set up for your, this is the S, to set up your variables. This part here is when we did the L and we set up our loop. This part here was our do, just to make it so as they could really see exactly step by step as you're stepping through that algorithm, what part of the, you know, the code you're coming up with. And I thought that was quite a good idea. I would quite like it with it like that, and, you know, sort of color coded.
Yeah, that's right. I mean, it is a challenging task, but I think just following the slide mnemonic and breaking it down, decomposing it, it will be possible, obviously, to answer the question. So here's another quite challenging task. I don't know if some of you have seen this, but the washing machines task. So the first question looked at data flow. I know I've got, obviously looking at this here, I know that we have to complete step 3. So just as a reminder, we're looking at, I can see in step 1 that we pass out an array of records. And I can see
this is our machines coming out of step 1. Yep.
Yeah, that's right. And I can see step 2 gives me the slowest spin. So I know that's potential. That's basically a potential parameter for me to play with here in step 3.
Okay, yeah, because we've got the smallest wash and the slowest spin coming out.
Yeah. Oh. Okay. So also it tells me, it finds the price of the cheapest washing machine criteria. So what I'm thinking of is, what's the purpose of this cheapest price as well as found? Why do we have cheapest price and found coming out? So that also tells me it's finding the cheapest price and then a found variable to say whether something meets a criteria or not. So to work that one out, now I'm going to need to pass in my array of machines records. So we're
dragging machines over and passing that in.
So that's passing in. So passing in my array of machines records, and also going to pass in my smallest wash variable from obviously step 2 as well. Okay.
Okay, so now we have to think about which standard algorithms are going to be used here. And if we just look at our data flow in and out, we can figure some of it out. When we're using the word cheapest, we're usually thinking of it implies a small value. However, which version of the minimum algorithm, in our previous session, we looked at some alternative versions of the find max or find min algorithms, where we're looking at just finding it or finding the position of it, or using the position to find other bits of data from parallel arrays. It might not be a normal find min, because finding the name of the minimum doesn't really help us here. If we find the position of it, then that's getting us closer. So it's definitely the version of the algorithm we'd be using would be the finding minimum with extra criteria used as well. So let's look at how we can apply the slide algorithm to the question in the next slide.
What setup needs to be done here? So, well, I need to find out if I have found out something or not. So I will use a Boolean variable and set it to false to start with.
Okay. And usually they would set our cheapest price to find the place of the first item in the array. But because we've got the extra criteria that we're going to use, we can't assume that the first washing machine in the array is going to meet that criteria. So we've got two options the way we can do this. We could either iterate through and find the first machine that meets the extra criteria, or we could just set the cheapest price to a suitably high value.
Yeah, so that means our next step. Okay, that means next step on what to do now is our loop. So I think we know we had 80 washing machines, but I could just do the length of the array as well.
Yeah, candidates could do a while loop here if you've been taught that, but given that you would need to know the last one might be the cheapest price, I would just normally go for a fix loop here, I think, for the length.
Yeah, so next, obviously, we need to look at the decision part. So this decision part of the acronym has a few marks. So I need to check if it is bigger or equal to the smallest wash that I asked for, and the same for the spin speed. It has to be faster than the minimum I entered, and the last part of the decision is whether it is cheaper than my current minimum price.
Yeah, we need to remember here that we're using records, so we need to watch out square brackets to indicate that our index, that they're in the right place.
Yeah. Then obviously come to the extras. So, but we forgot the E in the acronym. So obviously there are extras, which we need to look at.
Yes, because once I found my cheapest machine, it did ask me to return the variable found as true or false. So I'll need to set it to true, as I've found a machine that matches the criteria.
Okay, so time for another evaluation. If you have a week or two before the exam, how do you develop your pupils' exam technique? How do you prepare them for the unexpected problem-solving type questions with unfamiliar context? Any comments or ideas, can you add it to a post-it?
Okay, I'm going to follow you to the next one. So yeah, if we've got any other ideas, I mean, I'm definitely using the slide acronym. I think I'm going to use some of the unplugged ideas with post-it notes and so on, just to vary it up a wee bit as well. Opportunity for people to discuss ideas with each other. Yep.
What I usually try and do with some of my pupils is, if it's like maybe in terms of peer marking as well, so maybe
Yes.
give the class like the same question to do, and if they all have that, like a copy of the marking scheme, and then if peer mark one another's as well, I always try and tell them to be really harsh with one another, and it can get quite probably get a wee bit.
It gets a bit heated then.
I know, and that's I know, but that's probably one of the good things is maybe if it gets like a bit competitive as well, maybe they're probably going to in some ways maybe try and remember, like if they've been maybe harshly marked,
yes,
then they'll maybe try and remember, right, that's something for me to possibly avoid in future. So sometimes things like that, I think, in a weird way, can maybe try and help some of the pupils as well. Maybe that's just
I agree.
my bonkers class, but again,
absolutely.
Anyway,
I did that with a software class test, like beginning December or something, with the hires, and quite a lot of my advanced hire guys are free at that time, so they just sit in the class and like they join in with discussions and things. But I got them to be like this sort of gatekeepers for the debates for the marking, and for them to explain actually to to the pupils why they should or shouldn't get that mark. So yeah, it was a good discussion. And like you said, hopefully they might remember that better than just me saying something.
Mm-hmm.
Sorry, Fiona, I lost connection there for a second. I'm trying to get back on.
Are you back on?
Wait, I'm just trying to at the moment.
Okay, we're just, I think.
I noticed that presentation had ended there, sorry.
Yeah, I lost connection there for
No
a
worries.
second.
Yeah, I thought you'd had enough, Lucinda, and just decided
No.
go and make. I thought maybe that caffeine had finally
Well,
worn off from that coffee.
Well, you were carrying on, so that's okay. I just trying to
We were just looking at some of the suggestions there.
Okay.
Google Jamboard, that's something I don't use. Oh, here we are. Here.
Oh, right. Okay, so it's a tool for PowerPoint.
Ah, okay.
I had used, what was the one that I had used and I picked it up from? The first STACS in-person meeting, I think it was Slido. I think that's maybe what it was called. And again, that was maybe an opportunity to try and sort of increase the interactivity for your PowerPoints as well, so that pupils could maybe, it was like the use of maybe QR codes as well. That pupils could scan and then they could fire feedback to you or answer questions using some of the QR codes. I thought that was quite good. Yeah, there it is there, in fact. Slido, that's the one.
Slido, okay, let's check that one out as well.
Aye.
I haven't heard of either of these. But yeah, anything we can get to increase their engagement, because it can turn a bit dry, can't it, when we're just revising towards the exam?
Aye, especially sometimes if you're going through a PowerPoint, you can maybe feel as if you're sort of waffling away to yourself. And again, pupils, you can probably see with the pupils' faces in front of you, that's usually an indicator.
That's right.
If they're still asleep or no, if their eyes are open, you're okay. But maybe any opportunities to try and sort of make it more interactive.
FigJam is pretty good, but I think it's discontinued. Jamboard is discontinued, or it's been replaced with FigJam. FigJam is very similar to this mirror board for anyone that wants to try use it.
That one there, that
and
quiz
it's also
look
free.
at that on Twitter. Aye, that I don't know if I'm pronouncing that right, but that's something I've kept telling myself I want to try and use, because when I look at their Twitter account, it looks really cool.
What's that one?
That one there that's just been typed in now, just the two of them, quizzes.
Oh yeah, quizzes, I use that quite a lot. Yep.
Yeah, pupils love to use that, quizzes.
There's a lot of these here, but maybe something we can have a look at, but I'm a wee bit conscious of the time as well, because we've still got
goodness, we're at 8:30, yes.
We've got a wee bit that we want to try and sort of forward on. So again, they're excellent suggestions. So there may be things for us to have a look at. But we'll try and round it up here.
Teacher account for life there from quizzes. That sounds good. My guys also like Blue Kit, actually, because they like to steal gold off of each other.
We're just sort of trying to wrap up tonight's session then. So as a quick sort of look back at what we, the SDD team, what we've done over the course of this upskilling event.
Yeah, absolutely. If we think back to session 1 all those months ago, we looked at patterns in N5 in higher analysis and evaluation questions. And we looked at giving examples of good, okay, and bad responses, so that we could try and spot what makes a really good answer. This has been made into a printable resource, so the pupils can do the same and can categorize so that they can learn how best to structure their answers. So that will give them some scaffolding to begin with, won't it? So that they can then see in front of them what's an okay, what's a better answer, or what's a worse answer.
Yep. And then in the second session, we were looking at, and that was probably one of the more trickier ones, parameter passing and data flow at higher. So discussing sort of the methodologies for answering your data flow questions, and they were made into, I think that they either were or are going to be made into a resource as well that can be used.
Yes, we also proposed the idea of using skeleton stubs, building a modular structure of the higher program with data flow implemented, but without actually writing the module code.
Yeah.
Okay, session 3, obviously we looked at standard algorithms and the different variations that might arise. We also obviously used the SLIDE acronym to support people to learn the higher algorithms. And we also discussed debugging tools and the various IDEs available and how best to use those debugging tools.
Yeah, so the resources from this session, they'll use the sort of variations of the algorithms, and we can again ask the pupils to identify what the slide parts of each chunk of code.
Yeah, and finishing off this evening with our computational thinking approach to solving problems, as well as encouraging pupils to mentally decompose problems and spot patterns in order to solve bigger, more complicated tasks.
Aye, and fingers crossed. We really hope that with the time and effort, particularly Tony and Mark have put in, and Brendan as well, that we can give you something useful that you can sort of take away from these sessions and use in your practice.
Absolutely, because we appreciate all the time that people have put into attending, not only ours, but the web and the database as well. Because this upskilling programme has been a new approach to upskilling in CPD.
Yeah, we would love to get your opinion on what you think we should keep in the course. But also, just as important is what you think we could basically remove from the future version in a program like this.
Yeah, and if there's anything you think that we could add, please do let us know. And on Saturday, there was quite a lot of enthusiasm for us adding as many printable resources as possible that people could guillotine and use as unplugged classroom activities.
Yeah, and obviously getting feedback and suggestions on various things that we could do differently to improve. Please grab a post-it and just add your comments, what you think we should keep, what you think we should drop, what you think we can improve. And if you think there's anything that we can add to improve the sessions, then please just grab a post-it and just type in. So getting feedback from you is would be really good.
Yeah, the more feedback that we can get, specific feedback, then obviously that can be taken into account for hopefully, planning STACS activities going forward. Because I think we want to keep the ball rolling.
Yeah, that's right. The board will remain open. If anyone wants to drop out of the meet, you're more than welcome to. But the more feedback we get, obviously, the better the sessions would be. It will help us move forward.
Yeah, because I think this year's the N5 and higher came as a result, the way it was done, of feedback from the advanced higher last year, wasn't it?
Yeah, a copy of the examples, definitely, because the slides went off a bit at the last slide. So you definitely have a copy. It will be available on the STACS website. Is 90 minutes too long or too short?
How many sessions in a week, possibly?
Yeah, that's okay, Ken. Thank you so much.
Aye, folks, if timing's a wee bit too tight for you now, then yeah, feel free to I know we're probably putting you on the spot with these sort of questions here, but even if you would maybe want to try and email them at a later date, you're more than welcome to as well. Obviously, time just now is probably a bit precious for all of us. Obviously, we're trying to do, coursework and exam preparation as well.
Absolutely.
So we really appreciate
Projects.
you turning up, not
Yes.
just for this session, but for all of them,
For
really,
all of them,
dedicating
absolutely.
that time.
Yeah, because we know how precious a commodity time is.
Yep, I know. Because you always think you've maybe got time to do stuff, and even if you just think in class, you always think you've got time to do things, and then something pops up, and your planning's out the window.
Yeah, so I think there's a wee pattern there, isn't there? Talking about actual answers and
Yeah, it seems to be a pattern here for what we should add by breaking down exam questions to identify the sort of answers that are expected.
And that might be a good resource to add. I know some teachers do have their own bank of here's a good, a mediocre, and a bad answer for, all of these questions in this year's paper. But I'm sure there's a lot of teachers that would be pleased to get something like that and work through it. And of course, we've got the evaluation board right at the end, just to remind everybody. Feedback to STACS would be great on the evaluation. There's also a link on that evaluation to get involved with STACS.
Yeah, there are loads of classroom materials that will be updated and downloadable.
Yes, absolutely. I think the videos from everybody's sessions are probably going to get some sort of, what would you say, indexing on them so that you can jump into particular points in the videos from the sessions if you want to listen or re-listen to, a particular thing.
Yeah, and get involved with STACS if you feel that you can contribute. The more heads we have,
Absolutely.
better.
Aye, folks, thanks very much for all your time this evening. I think there's a few people who are...
And thank you for all your feedback. Mm-hmm.
Yes, much appreciated.
Any additional information will be announced by email or through the usual STACS.
So folks, I think we are going to head back into the Google Meet. Just if there's any questions that you maybe want to ask, I think we're going to stop the Miro board there just now, and we're going to return back to this Google chat. So if there's anything that you want to stay behind and talk about, we'll be there. Obviously, the three of us, and also Tony and Mark. So if there's anything that you want to speak about, please feel free to join. I think we'll probably get about maybe 10 minutes or so.
Anna's got a question. Anna, can you unmute your microphone?
Hiya.
Hi.
I just got a question because next year I'm looking at doing advanced higher because I've got like 5 or 6 pupils that I feel are going to pass the exam. We'll see. My question is there a book? Because I looked in Amazon, I couldn't find anything.
For advanced higher,
I think the best we'd have is probably the Scholar textbooks.
Yeah,
the Scholar, Anna?
Scholar textbooks, or you can use Mark Hayes' website.
Mark's website is excellent. Can't speak highly of it enough.
It's in the chat. Anna, if you can just take a copy of it as well. Or the Scholar textbooks. I mean,
yeah, Scholar's good. It's just a bit long-winded, isn't it?
Yeah, I mean, it's for those people that want more detail and more explanation on various topics.
Yeah, well, for me as well to know how to split the content and stuff. So
yeah, that's right.
For a textbook, yeah.
Mhm.
We'll have a look at the website then.